Hey, welcome to Ask Elihu. CFB Edge came at us with a question on what is the best way to bet on season wins. He has three choices: over 4.5, 5, or 5.5, and he wanted to compare those prices. Which of these is the best bet? Now, whether or not you agree that over 4.5, 5, or 5.5 is the right price, one of these is clearly going to be a better price when you are betting the over. So first, we're going to look at the answer, and then I'll show you the methodology on how to get there. So you look. He has over 5.5 minus 120, and I'm going to assume it's a 4.5% hold, but you can change it if you need to. So on my spreadsheet, I put in numbers that give me an estimated win rate of over minus 120 on 5. And we see that over 5.5 should be plus 139, and over 4.5 should be 196. So going back to what he had, you can tell that clearly over 4.5 is the best play because these push rates are simply higher. But how do you get this answer? And the way to get this is you have to figure out the probability of each possible outcome of season wins. So we're going to break it down into a small piece of the problem first. Let's just assume each team plays 6 games at home and 6 games on the road. Now that's going to change by team, and the better teams tend to play more games at home. But we're going to make 2 assumptions, at least for now. For this problem, 6 on the road, 6 at home. And the other assumption we're going to make, which is not true but simplifies the problem, is that the odds of them winning each game at home are the same, and the odds of them winning each game on the road are the same. So I'm giving each team a simple rating, the odds of them beating a neutral or average team in a neutral field, and then we adjust it up if it's home, adjust it down if it's on the road. So what is the probability that a team is going to lose all 6 games on the road? And that's just a simple probability problem. If the odds of them winning are P, the odds of them losing are, Q is considered 1 minus P in gambling speak. If the odds of something happening are P, Q is the odds of something not happening. If the odds of a team winning is P, odds of it losing is Q. So the odds of a team losing 6 games consecutively, all 6 games, would be Q to the 6th power. What are the odds of a team winning exactly 1 game? The first thing we look at is, what if they win the first game and lose the next 5? That's an easy thing to calculate. Win the first one is P, lose 5 is Q to the 5th. So the odds of them winning the first, losing the next 5, P, Q to the 5th. But how many ways can a team lose exactly, or win exactly 1 game? They can win the first one, the second one, the third, the fourth, the 5th, or the 6th. So there's 6 different ways, and we did that by counting on our fingers. But there's a better way, and that's to use selections. In an earlier video, I taught about permutations and selections. And in this case, if you have 6 games and you're picking one, it's 6 choose 1. Which is 6 factorial divided by 5 factorial divided by 1 factorial. Now, with 6, it's easy, when you're picking 1, but picking 2 is a little bit trickier. If you're going to pick 2, 6 choose 2, it's going to take me a long time to use my fingers to count all the ways it can happen. But the short way to do it would be, you're going to win 2, that's P squared. You're going to lose 4, that's 1 minus P, sum to the 4th. And then there are 6 choose 2 ways to win 2 games and lose 4. 6 choose 2 is simply 6 factorial divided by 4 factorial divided by 2 factorial. The dividing 4 and 2 are both on the bottom, 6 factorial is on the top. And you can do this for, you can actually come up with just a copy-paste routine where you say 0, 1, 2, 3, 4, 5, 6. If you're going to win, X games, it's P to the X, Q to the 6 minus X, and you're going to select 6 choose X games. And that gives you the probability of winning each exact number of games. When you're trying to figure out a full season, though, you have to create a grid. You want 6 games for home. You have another game for 6 games on the road. And you'll calculate the road wins the same way as you would the home wins, except that the probability will be a little bit lower. So if your average team is winning 60% at home, maybe they're going to win 40%. But you can use whatever home field advantage you think is the right number. One little thing to worry about with college football, you can't use the home field advantage for the whole world. When you're trying to measure the home field advantage between competitive opponents, it's best to use home field just measured in conference play, because if you don't, you're going to get exaggerated home field advantages when you have the stronger teams that typically play more than half their games at home. All right, back to the problem. So you get a probability of winning from 0 to 6 games at home, a probability of winning 0 to 6 games vertically on the road. You can then multiply those to figure out the probability of each outcome. Win 2 games at home, 4 on the road. You then create a grid underneath that, just copying your headers So you add up how many games each box wins. So if I win 4 on the road and 2 at home, I know that that's 6 games in that box. And you'll take a sum product to figure out the probability of winning each possible number of games. And once you know the probability of each number of games, it's easy to price every one of these and figure out the push rates. So now we're going to go back and look at the spreadsheet for a minute and play around. Now, a couple things to think about. If you have I'm assuming all games are equal. But let's say of these 12 games, there's one home game you're absolutely going to win, and one road game you have no chance of winning. Then the way I could fix that is I'm going to reduce the number of games at home and away by 5, and I'm going to add 1 to my imaginary result. So at 5 and 5, my new over under 5 is minus 150. Whereas if it's more competitive, it's less likely to go over. Another thing is the bigger the home field advantage, the more valuable each half game is going to be. So right now, going from 5 to 5.5 is about 60 cents. If we double the home field advantage, it goes up a little bit to about 65 cents. If we make it 0, it goes down to 58 cents. Now we can also do the NFL. I'm going to use an average team for the NFL. 50% against average teams. 8 home games, 8 road games, and 1 neutral game. There's a lot of games this year that will be on neutral fields. So if we do this, we see, if 8.5 is the expectation, half of your 17 games, the odds of winning 9 are, it moves not quite 60 cents. So, close to the middle, it's 60 cents. But let's look at a team that's not as strong. If we go a team that's going to win 30%, we see that going from 5.5 to 6 is 68 cents. So, and if we do this, go the same thing the other way. If we're looking at a team that's going to win about 70% of their games, you're moving, again, a little bit more when you're as you move away from 0.5. So that's just a quick primer on one way to approach it. Now, again, it's not perfect because if you have lopsided schedules, there are other ways you could attack this problem. You could use a Monte Carlo, but this is just an easy way where you could spend half an hour making a spreadsheet and get pretty good answers. And in this case, we don't know if the push rate at 4.5 is going to be 70, 80, or 90 cents, but we know it's a lot more than the 40 cents. So in this case, over 4.5 is the right play. If you have any other questions, send me a note at Betting Talk.